All right, up next we got Catherine. So yeah, Catherine, recent Women Who Code Award winner. Yes?
Maybe, yeah.
Yeah, well done. And what are you chatting to us about today? Code-worthy code, credit-worthy code. Thank you very much.
Thank you.
Big round of applause again.
Hi, nice to meet you all from afar. I'm Catherine, and today I'm going to be chatting to you a wee bit about credit-worthy code, which is essentially just how we can kind of redefine banking with a little bit of Python. So yeah, I'll start by telling you a little bit about me. I graduated here from Queen's in 2022 with a degree in biology. And then I worked as a pharmaceutical analyst for a wee while before getting a friendly referral to KPMG. Shout out to Alana in the crowd. And have been there for a data engineer for just over a year now, and mostly working with Python and really enjoying it. And it was actually within my first few weeks last year that I attended my first ever tech conference, which happened to be Women Tech Makers. And kind of, as Neve said, from peer encouragement and support and just recognising how kind of comfortable of an environment this was, I was inspired to talk today, and here we are. So enough about me. For the next 10 or 15 minutes or so, I'm going to take you through three main areas, kind of starting with the downfalls of legacy banking systems and why their big sister cloud banking should kind of step in and take the reins. And then an introduction to a specific banking provider called Thought Machine and how they kind of introduce total flexibility through smart contracts. So yeah, without further ado, the perils of legacy banking. If you don't know, legacy banking typically refers to the kind of traditional and quite frankly outdated architecture that most banks rely upon. And while that's served us well for the past 30 years or so, it has a few major problems. Starting with the fact that while there's multiple products in the bank itself, because of legacy technology, a lot of functionality is duplicated across those products. So this kind of creates quite a drain on resources where there's redundant functions and there's a lot of time, money, talent wasted simply just to kind of keep the lights on. Along with that, legacy systems are also quite disjointed. There's often multiple hosting environments for their products and systems, and they're split across multiple layers. So when it comes to data migration and extraction, this is super fun, not, as the bank kind of has no single source of truth for their financial data, meaning that they never really have a real-time view on what's happening. This is also not helped by the fact that legacy banking systems, they typically collect data at the end of the day in what's called batch processing, where the core is usually shut down for an hour or two, and then someone has to come along and aggregate all that data from the different systems. So by the time they've done all that, the data itself is out of date, and the bank can't really respond to anything quickly. So if, like me and the angry cat clock, you're thinking it's time for a change, I have the answer in the form of cloud banking. Cloud banking essentially is what it says on the tin. It utilises cloud computing to manage financial services and boasts a lot of advantages over its legacy predecessor in the fact that it kind of has seamless integration between its data and operating systems. So everything is hosted in one platform, and it has a centralised data repository that you can then use as a single source of truth for your data. So it means banks can gain immediate insights into what's happening with their customers and can respond quite quickly to any business changes or risks or anything. In tune with that, the cloud also boasts quite enhanced security because, like the real-time data streaming allowed from the centralized data repository, you can constantly be screening for any safety risks or bugs. And then with instant access to software updates, you can deploy anything without disrupting any services if something did happen. Alongside that, the real-time data analytics in the centralized data repository means there's room for lots of automation, so banks can respond quickly to anything that happens. And alongside that, products themselves typically might be in code or a lot more flexible than they are in legacy systems. So as opposed to typical legacy updates that might require quite laborious planning and very tedious and have very big losses and are quite risky if there are any failures, products can just be updated incrementally with version control and without disrupting anything that's happening. And overall, this leads to quite good cost efficiency for cloud banking, as there's massive reduced capital expenditure, since a lot of processes can be automated and resources can be kind of allocated to do more beneficial tasks instead of all the data migration, extraction, automation that was probably costing them lots of hours. As well as that, as I'm sure you know, cloud itself is typically a pay-as-you-go service and very scalable, so banks can manage their budget a lot easier. I'm just going to breathe for a second. And then, yeah, I'd like to introduce you to Thought Machine. Thought Machine are a core banking provider that I had the pleasure of working with on a project, and coincidentally are partners with KPMG. Thought Machine kind of set themselves apart by having a banking and payments platform that's cloud native. So there's no reliance on any cloud or pre-legacy code. Within that then, banks kind of have the option to run whatever financial service or product that best fits their needs on their Vault core. And this Vault core itself is split into 2 layers. You have the Vault platform layer, which is just common functionalities, and then the Vault configuration layer, which includes their universal product engine that kind of gives it the real uniqueness. And this is in the form of smart contracts. And what are smart contracts, I hear you ask? Smart contracts are essentially Python scripts that are written in Thought Machine's contracts API language, and they essentially digitally enforce the terms and conditions of the agreement between the customer and the bank, or in a cooler way, their financial logic as Python code. This means the smart contract can kind of handle all aspects of an account lifecycle, from account opening, account closing, and everything in between, like interest accrual or whatever tickles your fancy. The smart contracts themselves also adopt parameterization so that the bank can customize it to literally exactly what it needs. So to delve into those a little bit more, smart contracts are kind of focused around 3 key areas. So we have hooks, which are just a kind of funky Thought Machine way to say Python functions. There's around 12 hooks within smart contracts. So you can have these quite fundamental hooks like account opening, closing, and ones to handle payments. And these can kind of be mixed and matched in the contract. You don't need to have them all in there. And again, they can call helper functions that can do little interest calculations or whatever you need. The second aspect, as I mentioned, are parameters, which are essentially just any configurable aspect of the smart contract, like an interest rate or a grace period. And then these parameters themselves have associated metadata, like maybe default values or minimum and maximums, that allow them to be that bit more customizable. So in 2 examples that you may or may not be able to see, I'll just talk through them a wee bit. Example 1 shows a hook, which is called the pre-posting code. In Thought Machine, a posting is essentially any movement of money or funds between customer accounts and addresses. So the pre-posting code would typically use conditional logic. In this case, it simply just says, if it's not in pounds, then reject that and show that message to the customer. Typically, it would be a lot bigger than this, and it would iterate through the conditional statements. And then when it reaches the end, if it's all good, the posting will be accepted and committed to the bank's general ledger, and then move on to the post-posting code to maybe be split out to further addresses. Like if it was a loan, this could dedicate certain amounts to interest and then fees before paying off the principal, and vice versa. If it's rejected, it might maybe call another function that sets a flag on the account for making a posting in the wrong denomination. And then on the right, there's a wee overdraft limit parameter with a nice hefty value of £10,000. We would all like that. And then you can see the metadata that I'm talking about, or you can set your own minimum value, the step, which is just how much you increment it by, your display name and description, that will be shown to the customer, your name, the type, and then your level, which in Thought Machine, a level is essentially just the scope of the parameter. So in this case, a template level means this parameter would be across all accounts under one smart contract or product, whereas you can also have instance if you wanted it to be quite specific to one account, maybe based on credit limits or whatever, and global parameters that are across multiple accounts under multiple smart contracts, like maybe the Bank of England base rate, for instance. Oh, is she gonna move? Yeah. Like all good code, smart contract code can and should be tested to ensure that the financial behaviour is working as expected. As developers, we carried out 2 main types of testing on the smart contract code, these being unit tests, which essentially just tested the smallest units of the code, being the hooks and any helper functions. It would just run the function and assert that it's doing as expected. For instance, if it was an interest accrual function, Thought Machine itself has double entry bookkeeping, so every posting that's made has a credit and a debit, and the unit test would essentially just have the 2 posting calls in it and assert that those have been made when the posting has been run. But if you want to get a bit snazzier, we also have simulation testing, which uses a mock fault or essentially like an in-memory approximation of a fault instance against their simulation endpoint to mimic how the smart contract would run in real time. And I've popped a wee example down there that you might not be able to read, but we'll run through it anyway. This is just a wee example of a loan simulation test where we make an inbound hard settlement, which is just an example of a posting type of £1 to a loan with a principal of £3,000. And this is just to validate that any payment that's a credit payment under the debt of the total loan will be accepted. So we use an expected balance time series, and we say that the expected balance after this posting is going to be 2,999, if my maths is correct. And then we run that against the simulation and verify that the simulation output and the expected balance validate, and you'll get a nice green tick if that's the case. These simulation tests can be really handy, as with Thought Machine, you can have a debugging function where you can add logs and quite literally see every single thing that happens within the simulation time frame. So you can see from start to finish all the accounts being set up, the principal balance being dispersed right down to that wee £1 payment. And when it came to defects on the project, this came in very handy, as you could literally go and view what happened before the identified defect and mimic those exact balances in the simulation, and then you could make the posting that maybe caused it to go skew with and see if it was a smart contract logic causing issues, which in some cases it ended up a QA tester and went a bit rogue and made like negative fees, and then there was like a minus in the smart contract somewhere that turned into a plus and everything went a bit whack. But through the simulation tests you were able to identify that really easily and just say take the maximum value of that or 0. So to me, that's all pretty nifty. And I think it ultimately kind of allows banks total control over what they want to do, which they don't really have right now. As the product as code approach allows them to like design, build and test whatever best meets their customers' needs, and not even that, but also get a little bit creative. I don't know, maybe they'd want to have savings account that could link to AI. Maybe Emily, wherever she went, could help out. And the savings account could pop money into pockets based on your spending for that month or whatever, or maybe a virtual financial assistant that might say, hey, Mercury's in retrograde, stop spending so much money on coffee. Or maybe more boring ones like instant loan approval, where it could stream credit scores live and define your loan terms and accept or reject it without any manual effort. Or even a bit rogue, but crypto-powered mortgages, where essentially you could use cryptocurrencies as collateral, and then the smart contract would stream current trends and tell you whether to refinance your mortgage or not, or what's a good time, or essentially just anything that could make you or me rich, if you want to give me credit. I don't know if you were a little bit excited about that, but before I learned about Thought Machine at all, to me, financial services seemed incredibly boring. A current account just seemed like my current account. I thought there was nothing behind it, and maybe in legacy systems there's really not at all, but kind of learning that you can get a bit developing and a bit codey with banking, I don't know, opened me up to a new light with it, and I kind of love FS now. So if you got a tiny bit excited at all, here's some resources. Even if you're not excited, maybe pretend to scan them with your phone for emotional support. But from left to right, that one is just the Thought Machine Enablement Portal. You can sign up there if you'd like to learn a bit more about Thought Machine yourself. They have a Fault Core Fundamental certification that kind of takes you through everything that Fault does. And within that, they also have labs where you can kind of use smart contracts and design, build, and test them yourself, see how they work with Apache Kafka and whatnot. The second link is just the Thought Machine's website if you want to learn about what they do, or any banks that have them implemented at the moment. And then on the right, if all that went over your head and you're like, what's Python? There's some beginner Python courses to get you started. The first one is the Cisco Networking Academy one. They have Essentials 1 and 2 courses, and you get snazzy little badges you can add to your LinkedIn. And the second one is just Code Academy, which is great for anyone kind of looking to get into code, as it covers a really wide range of languages. And yeah, that's me. Feel free to email me if you want to just say hi, or add me on LinkedIn, or find me after this. But thanks for listening to me today. I don't know if anyone has any questions.
Do we have any questions? Any hands? Oh, yep, okay, coming up. I'm curious what, afterwards there'll be more discussion about hatred-wise, TransLink or legacy banking. Both well loved.
just a quick one on like FX gains and losses. I know it's more applicable for large companies, but seeing as your banking would be cloud-based, assuming it would feed straight into your accounting cloud-based system, does it account for like an FX gain or loss? Like if you made a payment in a different currency and you maybe made a loss or a gain on the exchange rate, would it account for that?
Yeah, Thought Machine itself kind of has these supervisor contracts which can go over other ones and account for multiple currencies. So I think so, yeah, but I'll get back to you on that. Not right now.
Thank you. Any others? Nope. All right.
Cool.
Thank you so
Thank
much.
you.